Assalamualaikum and greeting. I'm Mohamad Syakran bin Adenan will deliver a presentation on my final year project proposal. The title for my final year project is Design and Analysis of UiTM Formula SAE Car Transmission System. My project will be supervised by Professor Madya, Engineer Dr. Amir Radzi bin Ghani. Society of Automotive Engineers SAE have held an annual competition called Formula SAE. SAE will give rules and specifications for the participant to follow in order to design, build and test their Formula type racing car. This project is focused on the transmission system of the car. Using CATIA and ANSYS software, this study will analyze the design of transmission system and perform any required changes to make the design is usable, at the same time fulfill the given rules and specification. To make the car move, the power produced by the engine need to be delivered to the tires. That is what the transmission system are for. It will receive torque from the engine and deliver it to the wheels. All of the components in the transmission system will receive high torque produced by the engine while transfer it to the wheel. Therefore, the components are put through high stresses and torsional moment. One of the components in transmission system are differential. The function of differential is to split the amount of torque going to each wheels. This will allow the wheels to rotate at different speed when cornering. The differential will be mounted to the chassis to secure its position. Moving on to literature review. First, the focus will be on the differential, followed by differential mounting, and finally, material selection. There are many types of differential available nowadays in the automotive industry. The first type of differential is open differential. Open differential will divide the torque from the engine into two outputs for two different wheels. This will allow the outer and inner wheel to rotate at different speed. Next type of differential is locking differential. Locking differential can deliver the power from engine almost 100% efficiency to both wheels while allow differentiation while cornering. Furthermore, limited slip differential is also widely used in automotive industry. The limited slip differential consists of friction clutches. If there is difference in torque on the differential gear and spring preload, the friction clutches will engage. Limited slip differential is commonly used in Formula SAE car, so does in UiTM Formula SAE car. A good design will require less maintenance to be performed on the differential. The second criteria is to design lightweight differential. Differential mounting is used to hold the differential firmly to the car. While supported mounting can be defined as mounting is able to withstand the weight of the differential and hold it firmly while the car moving. The purpose of this is to ensure the alignment of chain sprocket is maintained. For that reason, the location of the mounting itself needs to be placed on strong foundation. The highest strength on the Formula SAE car is on the engine due to the whole design is based on the engine. Thus, transmission mounting is best to place on the engine to take its advantage of high strength. Material selection for differential mounting need to be chosen from material that have good fatigue properties. The power produced by the engine is transmitted to the wheel through the transmission system and transmission is mounted on the bracket. The material for differential must be able to withstand the forces produced by the engine during braking, acceleration, and cornering. The 707-T651 aluminium alloy have excellent mechanical properties with ultimate tensile strength of 651 MPa, yield strength of 500 MPa. The T651 aluminium alloy have good ductility, have high strength and good resistance to fatigue. The main challenge faced in designing the transmission system is that the design should be made with taking consideration of limited resources and funding. The cost of fabricating the design should be as low as possible, since there will be evaluation on the cost of fabricating the product during the competition. Poorly designed any parts in the transmission system can lead to failure such as fracture due to fatigue. The objective of the study will be: number 1, to design a proper and usable transmission system for UiTM Formula SAE car using engineering CAD software CATIA. Number 2, to perform an analysis on the design of transmission system for UiTM Formula SAE car using engineering CAE software ANSYS. And number 3, to determine the best design of transmission system for UiTM Formula SAE car from the analyzed design. The study of designing transmission system of UiTM Formula SAE car will be consist of differential and its mounting. Parameter and dimension of the components are determined from previous Formula SAE car design. The study continues by making improvement on the former design of transmission system for better performance. The design process will be performed by using CAD software called CATIA. Next, the design will be analyzed by using CAE software ANSYS to fully understand the behavior of the design when force is applied. Moving on to methodology, the first phase of the project is to collect data and information regarding the project. Initial collection of data is made by researching through past studies, research papers, and articles. Research paper regarding the Formula SAE car can be accessed through SAE official website. After collecting enough data from previous study, it will be used to come out with various design with analysis. Second phase of the project is design modeling of the transmission system. The model was designed using computer-aided design software CATIA. The above image is the former design of UiTM Formula SAE car, and the image here is the close-up of the location of the differential, which is at rear side of the car. The main reason CATIA software is used is because of the former design was already in CATIA format. For the next phase is design analysis. To analyze the design, ANSYS software will be used. Finite element analysis (FEA) will be performed to the differential mounting design. The FEA is a technique used to predict the behavior of various types of physical systems like deformation of object affected by vibration or applied force by using computer. With correct input, meshing and boundaries condition, the result for the analysis can be near precise as performing the test physically. The last phase of the project is analyzing the data. The data received from performing finite element analysis on the drawing will be studied thoroughly. Any deficiency in the result of the analysis will be rechecked and redesigned until the design meets the requirement. For preliminary outcome, product design specifications have been made for the differential mounting. The mounting should be able to firmly accommodate the transmission system, especially when the Formula SAE car is moving or stopping. The mounting is capable of withstand the force and vibration exerted from the transmission system without any damage or occurrence of deformation. From data and information gathering, first design of differential mounting was made. The bracket is located in between the sprocket, which receive torque from the engine through chain. The bracket will support the weight of the sprocket and limited slip differential which connected to the sprocket. Initial calculation of the force applied to the differential have been calculated. The summation of moment equal to 0 is derived from Newton's second law of motion for x and y direction. By assuming the value given, it can be calculated that the maximum rear wheel torque during acceleration is 742 Nm. Another estimation is made to determine the total torque produced by the engine. The engine used for UiTM Formula SAE car is engine from Kawasaki ER6. The engine approximately capable of producing crankshaft torque of 65 Nm. The torque received by the differential will be at max when the transmission is in the first gear, allowing for primary, secondary, and transmission drive reduction. The differential will see a maximum peak torque of 1505.8 Nm from the engine. In conclusion, the final result is expected to determine the best design of transmission system for UiTM Formula SAE car based on analysis. That will be the end of my presentation. Feel free to contact me if you have any question regarding the presentation. Thank you. Have a good day. Assalamualaikum.